Basic electrical terms 5. What is resistance? The flow restrictor. Our fifth question is, what is resistance, and why is it necessary for controlling the flow of electricity? Simply put, resistance is the opposition or friction that a material offers to the flow of electric current. It's the traffic jam for electrons, measured in ohms. Resistance is measured in ohms, /omega, named after German physicist Georg Simon Ohm. 1 ohm is defined as the resistance that allows 1 ampere of current to flow when 1 volt is applied across it. The water analogy, friction. Returning to our water analogy, if voltage is pressure and current is flow, then resistance is like the narrowness or roughness of the pipe. The smaller or rougher the pipe, the higher the resistance, and the slower the flow. The atomic cause. Resistance arises because, as electrons move through a conductor, they constantly collide with the atoms of the material. These collisions impede the electron movement, converting some of the electrical energy into heat. The necessary opposition. While it sounds negative, resistance is essential. Without resistance, current flow would be unlimited, leading to massive short circuits and device destruction. Resistance is what controls the current in a circuit. The role of resistors. In electronics, components called resistors are deliberately added to circuits. Their primary function is to provide a specific, calculated amount of resistance to limit the current or divide the voltage. Factors affecting resistance. The resistance of a wire or component depends on 4 main factors. The material, copper is low resistance, rubber is very high, its length, longer wire means more resistance, its cross-sectional area, thicker wire means less resistance, and its temperature. Ohm's law in action. Resistance, R, ties all 3 basic concepts together. According to Ohm's law, R is equal to VI. This formula shows that for a fixed voltage, increasing the resistance will cause the current to decrease. Conductors versus insulators. Materials with very low resistance, like metals, are called conductors. They allow current to flow easily. Materials with extremely high resistance, like glass or plastic, are called insulators. They prevent current flow. Why heat is generated? The energy lost in overcoming resistance is dissipated as heat. This effect is useful in devices like toasters and incandescent light bulbs, but it represents wasted energy in power transmission lines. The power equation link. The power, P, dissipated by resistance is defined by P is equal to I to R. This is why electricians worry about high current, I, in wires, as it quadratically increases heat output. Final control point. Resistance is the fundamental property that allows us to manage and harness electricity. It limits flow, dissipates energy where needed, and makes the operation of complex electronic devices possible.